Welcome back. Problem number 79, word search. Given an M and N grid of characters called board and a string called word, return true if word existing in the grid. And the word existing in the grid, if we can match it, the word can be constructed from letters of sequentially adjacent cells where adjacent cells are horizontally or vertically neighboring. Okay. We can do this. How can we do this? Oh, this is a great question. Let me think. So we have these characters like this word like A, B, C, C, E, D, A, B, C, and E, but E doesn't. Another C, but this is not another C. We can do this. We can search for the word vertically and horizontally. So we can find A, B, B, C, but we don't have E here, so we stop, we go here, we have C, we found right, left, nothing, here we find E, and there we found E. But how can we do that? I guess we can create a depth first function that will try to visit each cell, and and from each cell we try to have some sort of index variable that we will try to increase each time. And like, for example, if we find A and A is the word, so the index will be 1, so we search for the second character of the word, and we continue until we reach the end. If the index equals the length of the word, that means we find the word, basically. Let's try to think how we can do this, but first I would like to just make some two variables, the rows, which will equals the board dot length, and const the calls, which will equals I guess board of 0 dot length. Let me just put this copy so it will be way more easier for me. Yep. Okay. So since we have our two variables here, I guess we can create a function, a depth first function, depth first. I have a bad pronunciation. Depth first function that will take 3 arguments. The first one, it will be row, the second one will be column, and the third one will be the index that will try to track for each character in the element of in the word string. Okay, since this will be a recursive function, we need to find our base cases. And I'm trying to think about 2 base cases. As we said before, if the index equals word.length, if that was a case, there is something wrong happened, we should return true. What did happen here? Let me see. Yeah, I get it. This should be an arrow function. Okay, we should return true. Okay, so if the index equals the word length, that means we actually find the word. However, let me see other thing, that we need to check if the current cell is out of bounds or doesn't match the current character in the word. So first, if we want to make sure that it doesn't match the current character of the word, it's pretty easy. I will say board of row of the column. So we right now on that specific character, if it doesn't equal the word of index, if that was the case, we'll return false. Also, we want to make sure if the cell is out of bounds. So first we will do 4 more checks. So I would say if row is less than 0. Okay, so if row less than 0, this condition checks if the current row is less than 0. If it is, it means we have moved out of the board's boundaries towards the top. This is important because we do not want to access a row that doesn't exist basically. And also if row is bigger than or bigger than or equals rows, this condition checks if the current row is equal to or greater than the number of rows. If row is greater than or equal to the number of rows, we have moved out of the board's boundaries towards the bottom. Okay. Also, if call less than 0, this condition checks if the current column is less than 0. If that true, it means we have moved out of the board's boundaries to the left side. Similarly, the row check, we do not want to access a column that doesn't exist as well. And also here, I want to say if the same, if call is bigger than calls. Okay. If call bigger than call, this condition checks if the current column is equal or greater to the number of columns. If call is greater than or equal to the number of columns, it means we have moved out of the board's boundaries toward the right. If that was the case, we return false. Okay. So we have two things here. We stop the function executing the function for. After that, we need to continue because we have to make a recursive calls. So we need to mark the cell as visited by modifying its value. It's pretty important because we need to memorize every cell because we don't want to visit the cell over and over and over. So I will say const temp, which will equals board of, did I put board right? Yeah, board of row and column, and this will be the temporary, and I will put the board row and column. I will change its value as to make it like something like that. That means it is visited. And after that, we need to explore all 4 possibilities because let's you can see each one has its own 4 possibilities, like 1, 2, 3, 4. This one has 3 only. But if we want the top, that means the row we're going high to the top, and all of our conditions will prevent these type of behaviors. Okay. So right now we marked, we explore all 4 possibilities. We mark the cell are visited by modifying its value. We need to explore all 4 possibilities: directions, up, down, left, and right. How we can do that? We will have like we create a found variable first, const found. And basically, we need to get at least one true. Like for example, if we are in this C, we will try to all the possibilities like right, left, and down, top. There is no down. We try all these 3 possibilities, and we basically try to see if one of them at least true. The B is already visited, so we will not do the B. So we have the E and the C, and we need to find one of them at least equals to true. One of them at least equals the index of the character of the index that live in that word. So we will have do it like that. Diffs first. First we do it. We will move down first. So we call the diffs function again. Row plus 1 because we want to move down, and we put the columns as it is, and the index will be plus 1. Okay, right now we moved down. After that, we want to move up. So how we'll do that? Let's just take a depth first function here, and it will be rows minus 1, and we put the columns and everything still there. Okay, we want to move right now left and right. How we will do that? Let me just think. Okay, let me move right. How we can move right? Let me copy this. If you want to move right, I guess we will keep the row as it is, and we will make the columns by 1. And if we want to move right, sorry, if we want to move left, we will do it as well as taking 1 from the column. And if found is true, at least we need to find one of these are true. If found is true, we restore the cell value after exploring it. It's really important to do that. So how we will do that? We have temp, so it's pretty simple. We just do it like that. And after that, we return found. And when we return found, basically this is how the depth first function works. We need to call it, so we will iterate through each cell in the board, and we try to call it. We call each function on it. So let's try to, before going next, let's try to just make a memorization here. So the main function called exists, and it's responsible for checking if the word can be found in the given board. We have the depth first function. It's a depth first function. It's used to explore all possible paths from the current cell to see if we can find the word. Think of it as going as a going task 3 arguments. For example, we have row. Um, sorry. Think of it as going to step by step in all directions until we either find the word, or hit a dead end. Basically, first we takes three arguments. We have row, which is the current row. We have the columns, which are the current columns. We have the index, which is the current position in the word we are trying to match. After that, we have the in the depth first one function works like this. First, we if we have matched the entire word, which is the index, by then will the index will equals word length. We have found the word, so we return true. However, if the current cell is out of board boundaries, or the character in the board doesn't match the character in the word, that means we cannot continue in this direction, so we return false in this direction. If the current cell matches the current character of the word, we need to mark it as visited so that we don't use it again in the same path. We do this by temporarily changing its value to a hash, basically, here, as you can see. After that, we then explore all 4 possible directions, down, up, right, left, to see if we can match the next character in the word. We move to here. We move to we move down. Here we move up. Here we go right. Here we go left. And after exploring in all directions, we need to restore the origin. We need to restore the origin value of the cell. This is called backtracking, and it allows other possible paths to use this cell again. If any of the directions return true, it means we have found the word, and we return true from the depth first function. If if none of the paths work, we basically return false. The main loop, again, we will have a main loop here. We will create another loop and call the function on it. Let's just create this loop for which have let row equals 0, and the row should be less than rows, and the row plus plus. Okay, and I'll make another for loop here for let the column equals 0, 0, and the column less than calls, and the column is plus plus, and again we will do this if basically if the board, let's try to do it like that. If the board, let me copy this board because I guess I'm stuck up from writing this word. If board of row of column, if the character at this position, okay, equals equals what? Equals the first element of the word, if that was the case, and if and the depth first function of row column, and we put the first index which is 0. If both of them is true, we return true. Basically what we're doing here, if the board, if the first element, if the character at this position equal the first element of the word, we will call the depth first function to make sure if from that position can we actually match the word or not. We return true, and if we didn't return true, we should return false here. And let me run the function to see if I'm doing it right or not. And there is a problem here, confound invalid left side assessment. What is is the problem? Yep. Okay, let's run again. What is the problem here? Unexpected token. Where is the for loop? Yeah, let's run again. If board of column index cannot read the properties of undefined reading call. Okay, what is this? If board, let me see why. If board row the column doesn't equal, okay, let's make it this one in the end, because that means we make sure there is no reading of undefined, because these checks go first before that. Okay, that works. Oh, that works fine. Let me submit and see how later, please. Okay, we're killing it. We are killing this. Okay, so yeah. So yeah, I'm so proud of myself. I'm really like, after solving any problem in LeetCode, I feel that I am the king of this world. I feel like the world is my kingdom. I feel like a god right now. It's a great relief, to be honest. Okay, we can discuss this one. So after exploring in all directions, we go right on. Okay, sorry. If we want to talk about this, the main loop in the exist function starts the depth first from any cell that matches the first character of the word, and we said this before. And if any of these paths succeeded, we return true. And this solution ensures that we explore all possible ways to find the word while making sure that we do not reuse the same cell more than once in a single path. So that's it for this video, and see you in the future.